Alrighty, so let's have a look at number 1 here on this new booklet. It asks for the minimum value of the following sinusoidal function, y equals 12 times sine of x, 8.37x plus 36. So the easiest way to likely do this is to actually graph it, okay? Now probably what's going to happen is you're going to have some calculator issues. So clear out whatever y equals you've got in there, okay? If you've got stuff in your stat plot, you want to turn it off, okay? Stat plot means graph the data, not graph an equation. It means graph the data. So we're going to go second function stat plot, which is our y equals. And if you've got anything turned on, then you need to turn off those stat plots. Okay? Now in your y equals, you're going to type this in. So we're going to go 12 times the sine, I said times the sine, of 8.37 x plus 36. All right. Eh? Why did you put the x? Oh, yeah, that's not good. Well, that's a good chance for me to show you how the insert works, isn't it? So I'm going to go to right there, and I'm going to go second function, insert, and I'm going to put an x. Okay. Now, when we graph it, we're likely going to get some crazy mumbo-jumbo, right? You have to sort of understand a little bit about the graph before you can set the window. Now, Rowan, did it work when you did Zoom Fit?
No, you go Zoom 9 with your...
Well, Zoom 9 only works when you got stuff in your data and you're doing a stat plot. So it's not going to work if you've got an equation. So, well, it depends. You sort of got to know something about the equation itself. Okay, so in this case here, let's just do this. Okay, so there's the equation there. That's a 12, right? Do you remember what this d value was, what the plus 36 was? Remember on the graph, what is the median? That's the median. So we know that the whole thing is sort of centered around 36, right? So my y has to be, well, the center of the screen has to be at 36. Okay, so let's go back and let's change our window so that, let's go to our y. Now the minimum here is 36 and the max is 63. So I got to go like below 36 and above 36, right? How about we try, I don't know, we'll try 30 and 40. How does that sound? 30 and 40. Okay, just to start. Now my x min and my x max. Now we have no idea what to guess here. I'm going to just say, let's just take a wild guess. And I got 0 to 15. Well, let's see what that looks like. When I graph 0 to 15, I get something like this. So it yeah, lots of mumbo jumbo. It looks to me like it's graphing like up and down a lot, right? Sort of. Do we need to go all the way to 15? It looks like going to 15 is way too far, doesn't it? So let's cut it way back to, I don't know, like if this is 15, then that's going to be about 7.5. Yeah, Bob might be right, maybe 2. Let's go to our window. Let's go from 0 to 2. Now, did it look like we went far enough up and down?
No.
Didn't, right? So maybe I should go instead of 30 and 40. How about I go? No, you got to go below 30, right? No. Not. You got to go wider. 20 and 50. Go wider. Let's try that.
Too big.
There you go. Right? It really just comes from sort of playing around a little bit. Okay. So now we've got our graph. How do we find the minimum? Do you guys remember how to do that from yesterday? Yeah, exactly. So we're going to go second function, calculate, minimum, number 3, left bound and right bound. So remember we have to put the little cursor thingy to the left of a minimum, press enter, to the right of a minimum, press enter, and then we guess and press enter. And it finds my minimum is at 24. That was a lot of steps. The minimum's at 24. Is there another way that we could have come up with that?
You could have put your y at 0.
Well, I don't think that would have worked, Steve.
Yes, it does.
How about I remind you of the equation, which is 12 sine 8.37x
Plus 36.
plus 36. Rowan's on the right track. If 36 is the d, what's the number in front, Rowan? Do you remember from yesterday? It's the amplitude, which is the distance up to the maximum as well as down to the minimum. So the minimum is actually just the d minus the a. It's 36 minus 12. We didn't need to do any of that graph and stuff.
Would maximum just be padding?
What would the max be, Rowan? Excellent question. The maximum would be d plus a. Very good. 36 plus 12. 48. Give yourself a sticker, Rowan. Peel it off a banana and stick it on your fridge or something. So really, finding the minimum and the maximum from the equation is pretty easy. Okay, that's why it's just a single multiple choice question, because it's actually pretty easy. All right, can we move on to 2A? Do you think?
Yeah, you should give more time.
I'll give you some more time for 2A. Sounds like a good idea. Okay, so I'm going to punch in this data here. Remember to clear our L1 and our L2. Don't delete. And it says here, 2A, assuming that January is month number 1. So in other words, put 1, put 2, put 3, and so on in your list 1. In list 2, we're going to put the other numbers. So 838.9. We're talking a water level above sea level here, right? 836.2. I'm not sure why water level would rise and fall sinusoidally, but
Just to make sure that's my question.
okay, so I got my data in there now, and you'll remember to find the sinusoidal regression. We're going to go stat, calculate. I'm going to arrow up because that's the faster way to find sine reg. Oh, and I forgot to clear my home screen before I did that, so I got to do it again. Stat, calculate, sine reg, L1, comma, L2. And then remember to put it into our y equals. How do we do that? Oh, I did it again, didn't I? Comma, vars, y vars, function, y1. So that, again, remember, means take the data that's in L1 and L2, do a sine reg, find the equation of the line of best fit, and store it in L1, or y1. Right? Press enter. There's our equation. It should have stored it into y1. To see a nice graph, because I'm doing a stat plot here, because I'm graphing data, I can go zoom 9 for zoom stat. Now, why won't that work? Oh, Mr. Bennett. That's it, I quit. No. Why is it not graphing? It's because earlier today I turned off my stat plots.
Oh, no.
So I'm going to turn my first stat plot back on. And I'm going to try again. Zoom 9. There we go. No sense giving up. Does that fit the data? Not too bad? Not bad. Not bad. Okay. So our equation then is this value right here, right? This is our equation right here. Now I heard Roland say, oh yeah, we can't really do B quite yet, can we? Because yeah, you did. You said we can do the maximum and the minimum. Yes, you did. All right, we're going to need to do a little bit. Did you say that, Luke? Sorry.
I said there's. I didn't say we couldn't do it. I said it would be ridiculous to draw a sketch of something that goes up.
Okay. We're going to have to do a little bit more learning before we can do that. All right. So the question is, given the general equation, y equals a sine bx plus c plus d, what do the letters A, B, C, and D represent? Now, you'll already remember, right, that the D is equal to the median. In fact, I think I have a spot right here, right? So D is the median, or the midline, I like to call it. It's the line that goes right down the middle of the graph. That's the D value. Okay? So in fact, you could actually label that with a D, couldn't you? And the A value is that distance there, right? Which we call the amplitude. So in other words, what happens when, I'm just going to show you a little grapher thing here. Can you guys see that graph right there? I'm going to reset that. Can you see that graph right there?
Yes, we can.
Okay. So when I stretch the amplitude, when I make the A bigger, what does it do to the graph?
Bigger.
It basically takes it and stretches it vertically, right? Okay. The A is the stretch vertical. So in fact, can I get you to write that down right here? Under amplitude, can we write vertical stretch? It's how much it grows vertically, up or down. Right? And if the A gets smaller, well, then it's not so much a stretch, it's more of a scrunch, right? You'll notice, you're right, Steve, when A gets right to 0, it becomes a straight line, right? Amplitude is 0. What happens when A goes below and it becomes negative? Just sort of flips it upside down, right? Negative A means it's upside down. Positive A, negative A. Positive A, negative A.
Wait, can I see negative again?
Oh, oh, oh. Well, it looks very much the same, doesn't it, right? It's sort of which direction does it sort of start? Like here it's starting and it's going down, right?
What are the other knobs?
Well, let's have a look here. The D, this now they've labeled things a little bit differently. They've got A, B, then they've got H and K. Okay, so the K on this particular app is the D. Okay, so what does that do? If the D is the midline, what does it do to the graph? If I go bigger, what does it do? It just goes up or down. It doesn't change the shape of it, it just changes the position. Okay, so I like to call D, it's the median, but I like to call it the vertical shift. Or position would be okay too, right? It's how far up and down it goes. It doesn't change the shape, it just changes the position, like Rowan said. Okay, so we've got vertical stretch and we've got vertical shift. What do you think about B and C? What are they likely going to be, you think? Horizontal shift and stretch, right? And the only question really is which one does which. Okay, so I'm going to reset this back. Now they've got the B. The B is the number in front of the X. Okay, so let's just see what happens here. So what would you say the B is? Would you say it's a stretch or a shift? It's a stretch, right? It's a stretch, exactly. Okay. So the B is, now the B is related to the period. It's not equal to the period, so I'm going to put period in quotations because it's not actually equal to the period. Okay? But I'm going to call it, it's the number that affects the period, is what I mean by the quotations. And we would call that one the horizontal, which one was it? Stretch. It basically stretches it out or scrunches it. Now, interestingly enough, when I'm going to reset here, when B gets bigger, it actually does what? It scrunches it, right? In fact, the period gets smaller. So when B is big, period is small. When B is less, period is big. It's sort of the opposite, the inverse of the period. And I'm going to explain to you what the how that works shortly. Okay, so that must mean that C is what we call the phase shift. Okay, it's the horizontal shift. So we call the C the phase shift or the horizontal shift, and I'm going to show you what that means. Come on. I'm going to reset here. I'm going to adjust my C. They call that the H here. See how it shifts it left and right? Okay. So that's what C does.
All the way down.
It just shifts it to the left or shifts it to the right. That's all. Okay. Now it sort of depends on whether your general equation has a negative in there. You can just barely see that, I'm sure. So this one has a negative in it. Mine has a positive. That determines whether it's left or right. I'm going to sort of just gloss over that for the time being. Okay. I'm just going to sort of gloss over for the time being. But those things are important. Okay. Those things are important. Now that helps us to do an equation like this. Okay. So there's just barely enough room at the bottom of that page. Let's do it right there. Can we do it? I'm going to have to do it with you for sure. Okay? Y equals 2.68 sine. There is, but I've got stuff over there. 0.54x plus 2.76 plus 838. Okay? I can guarantee you they're going to give you an equation and you're going to have to graph it. Okay? They're going to give you an equation and you have to graph it. One half of that is easy. The other half is challenging. I'll give you the easy part first. How's that sound? Out of all four of those, Rowan, the A, the B, the C, and the D, which one sort of made the most sense and was easiest to understand, do you think? The A, the B, the C, or the D? They're all equally confusing?
I don't know. They're all the same.
Well, that's true, but like which one of these guys here?
Like what they do?
Yeah, what they do. Which one's sort of easiest to comprehend, do you think?
D.
D, absolutely. Everybody always says that. D is the easiest, Mr. Van. And I agree, okay? Now, they're going to give you, on the provincial exam, they're going to give you a blank piece of graph paper. Ignore it. Okay? It makes it harder, I think. If you want to just put in a blank sheet of paper with your graph on it, awesome. I'm marking your exams. It's not a problem. Okay? So I didn't give you a graph on here. I think it actually makes it harder because you actually have to draw it to make it match. It's easiest when you're graphing them just to do this. Can you draw that freehand? Most people can. Okay, so go ahead, scrunch that in at the bottom there. Scrunch that in at the bottom. Okay? Yeah. Just drawing a wavy line at the bottom. There's nothing to it. Okay, so what is the D value from the equation? The D value is 838, which means right there, that's 838. That's pretty easy. That's pretty easy. Okay? Now, we already know my A value. This is my D. This is my A. How do we find the maximum?
Just add that onto it.
Add that onto it, right. So it's going to be 838 plus 2.68. That's going to be 840.68, right? The maximum right there is going to be 840.68. The minimum, you might need a calculator to subtract it. But it's going to be 838 minus 2.68. And I get 835.32. Here's where it gets a little complicated. If you can do that much, then you're in pretty good shape. A water break. Yeah. In fact, I'm going to have to take a little mental break here and make sure I know what I'm doing before I. So. All right. So what I've done here is I've created a graph of this on WinPlot. Okay, just to sort of get our head around this a little bit, kind of thing. One of the things, and I'm going to have to double check to see exactly what they mean by clearly labeled graph. I know from past experience that they want you to label the axis as well. So what's the value that I'm graphing on my x here? Like it's going up on the x by what? No, like you got to look at the data. Are we not talking about months? Here we're talking about months. Here we're talking about water level. I know that they assign a mark for putting that on your axis. I know that. Okay. Can we figure out, we've done the max and the min, right? We've done the max and the min. They've asked you to fill in those blanks, so you could go ahead and fill in the blanks with the 840.68 and 835.32. I think that I'm going to leave out the X stuff for now, for today, okay? I want to make 100% sure that I give it to you the right way. It's been a year or two since I taught this, so I want to make sure that I know how to do it. I want to make sure that I do it in the simplest way that you'll get it the easiest. And if I start doing mumbo jumbo, then we're going to confuse you. Okay, so I'm just going to pause and I'm going to leave that for the time being. Okay, the X. Let's try to look at the next question here, which says, scientists predict that climate change will have an impact on the water levels at Cedar Lake. Describe one possible change in climate and its effect on one of the values in the sinusoidal equation. That's a pretty open-ended question. What's one possible change in climate and how would it affect one of the values in the sinusoidal equation? Well, we all know that climate change is sort of also called what? Global warming, right? I mean, that's sort of the common man's version of it, right? So scientists predict that climate change will have an impact on the water levels. Describe one possible change in climate. So we might say one possible change, not water, sorry. One is higher temperatures. Now, none of us are climate change experts. There's no doubt about that, right? So they would probably give you a mark for something like higher temperatures. What effect would that have on a lake's water levels, do you think, if it's hotter out? It would decrease the water level? Yeah. That's certainly one possibility. The water level seems to go up and then come down and then go up and then come down. Probably why does it go up and then come down? Yeah, like it melts in the spring, right? And it goes up and then it goes down in the summer and then it drops and then it melts and kind of thing. So if there's higher temperatures, you might think that might lead to what? Lower water levels? An overall lower water level. The question is discuss or describe one possible change in climate, so that's a higher temperature, and its effect on one of the values in the sinusoidal equation. So if we had a lower water level, what might that do to the A, the B, the C, and the D?
Lower.
Which number? Which number would get higher or lower if the water level dropped?
Amplitude.
Well, the amplitude would mean if the A got smaller, then that would just mean that it would do something like this, right? I'll do it in blue. It would mean that it goes, whoops, I'm not doing a very good drawing here. Well, that should be going through there. You think that's what's happening?
Yeah.
Like it would just mean that the water wouldn't go up and down as much. I read lower water level. I read that as the whole thing does what? Can I copy that? Can I paste it? I'm reading the whole thing instead of being up there. It's in fact down there. What would that mean to the equation? Which one? The D. D would be smaller. I'm thinking that's the answer they're looking for. That an increase in temperatures would lower the value of the D. It would bring the whole lake sort of down a foot or two. And what would happen? The D part would be lower. That kind of makes sense? Kind of, sort of? Okay. Yeah, I need to do some look at the X stuff. Let's have a look at that stuff from yesterday. You know, those questions. You guys get the stuff from yesterday? Okay.
Their stuff sucks.
I know, that's why I left it to the end. I'm trying to give you the barest minimum that will get you through this exam. Well, would you want to try to remember this and be back in February?
No. Yes, but
No, these things, I'm giving you exactly the kind of question. I'm trying to make this as painless as possible. Well, I understand, Rose. Okay, so yesterday, you might remember doing, can you guys find yesterday's sheet? You probably need this one, Lacey. Brett will need it as well.
how much personal finance is that?
It's basically equal percent of each unit. It's like 8 marks of each unit. Sorry, 10 marks of each unit.
We're going more, you know.
There isn't. Suck it up, Buttercup. All right, here's what we're going to do. So flip the page on this one from yesterday. It says periodic functions on the top. The one I gave you today, I think, says periodic functions part 2, right? So find the one from yesterday. Flip the page over. Find the one from yesterday, Bob. Flip the page over. During class, you're asked to perform an experiment using a spring. You attach the mass. You then spring and record the following out. We did that yesterday. We found the equation, right?
Yes.
Then we figured out what will be the distance between the mass and 4 to 5 seconds. We did that. And we found out the mass, when will the mass be 60 seconds before the 5th second. That's what we did yesterday. Part D, this you can do today. Part D says, your teacher gives you a second spring. You attach the same mass to the end of the spring and compare it to the first pair. You note that it bounces higher and more often in the same amount of time. Create a sinusoidal equation which could represent this new equation. All right. Do I need to remind you how we did the first page, do you think? Yeah? Okay, we'll do that.